So moving on to velocity time graphs. So what we can do, this is actually the graph that was on the last video. You can see that from this section, from 0 to 15, we figured out that the velocity was positive 0.8 meters per second. The middle section was 0 meters per second, and then from 25 to 35 was negative 1.2 meters per second. Okay, so what we can do with that, though, is we can make a velocity time graph. So if we have our y-axis being velocity, and these look a little bit different. What we want to do is make 0, somewhere in the center. Our displacement ones, for the most, yeah, I guess we could for that one too. But with velocity ones, you're pretty much always going to have 0 right in the center, or somewhere close. And then what we're going to do is they're just going to be straight lines. They're all going to kind of look like a staircase type of a thing. Because if you have constant velocity, which is what we're dealing with right now, right? We're not dealing with things speeding up, just going constant velocity. On a velocity time graph, it's always a straight line, right? Every time, every time. So all you have to do is we figured out this was 0.80 meters per second. You're just going to draw a line at 0.8 until 15 seconds. The times are all going to line up, right? So 15 seconds to there, 15 seconds to there. And then this is the only part that looks kind of confusing though, where all of a sudden we just drop straight down. So as soon as we get to that point, we draw a line that just goes straight down. Sometimes it'll be a dotted line. All that's really saying is it instantly goes from 0.8 meters per second, instantly goes to 0. Now, in real life, you might be thinking that probably couldn't happen, right? You can't, it would be like hitting a brick wall, right? Like you would just dead come to a stop. Where this thing would probably in real life look more like, this. Or probably even more than that, right? Like you need time to slow down to get to 0. But for our purposes right now, we're just going to pretend that person went from 0.8 straight to 0. And we just draw that as a straight line down. Okay, and then you can see we go from 0, and then all of a sudden we go down to negative 1.2, right? And then just a straight line from there to there. Hopefully that made sense. And like I said here, just make sure that you know that the scales for time are going to be the same, but the scales up the y-axis are going to be very different, right? They're ones in meters per second. Now, if we begin with a velocity time graph looking something like this, we can figure out the displacement. And the way we do that is by figuring out, well, first off, you can remember that we're able to use this equation, d is equal to v times t, to figure out displacement, right? So we can do that with this graph too. And the way we're going to do that is we're going to figure out, okay, what was the velocity at that point? Well, it was 5, right? The time at this point, from there to there, was 15. So if I go 5 times 15, what I'm really doing is I'm figuring out the area of this thing. So the area under a velocity time graph is displacement. That's going to be important to know. You're going to need to know that for sure. Okay, so if we do that, well, I just kind of want to draw your attention to this too, because area is equal to base times height. Our base in this case is time, so 15, and our height is 5. Okay, and you can see if we do that, we get positive displacement when it's above the 0, when it's above the 0 dotted line I got going along there, which makes sense because we went positive 5 times 15. Down here, we went negative 10 times 20. That gave us a negative displacement, which makes sense, right? We were to the left of our reference point. And now here, just what I'm saying is that if a person was asked to figure out what the displacement from the reference point was, what you'd have to do is add these two together. So it's going to be this one plus the area below, which is pretty much what I have here, right? The first one, and then it ends up being minus because it's plus negative 200. And in total, our displacement would have been negative 125 meters. So I'm going to end that video there, and we're going to pick up with problem solving. Like you guys will actually start graphing here in the next part. to figure some of these things out. So I'll see you guys in the next video.